Very nice. I finished the first relay and haven't opened the second relay at all because I want to show you what will happen next. So let's focus on this part. Let me continue. I have here a very large set of relays, 10, 20, 30, depending on the number of relays I have. Great. What is the step I am supposed to do next? I am supposed to open each relay and right-click on it to access object properties. Then go to the communication parameters and start setting a group of settings related to the IP address, subnet mask, standard gateway, and ID. So of course, if I start going through each relay, it might take a long time. How can I save my effort and time? Quite simply, what happens is that I will skip this step, as I will not do it through the relays. So, what will I do? We will move to the next step, which I will continue with. After that, I will right-click out and then insert a new object, then IEC 61852 station. I come to right-click and then tell it to insert a new object and then tell it IEC 61852 station. Great, okay, I will come to this station, which is considered your SCD file or substation configuration description file. I will go to this station, right-click on it and select object properties, then go to something here called the communicator. Through this communicator, I tell it which relays you want to add to your substation configuration description file. Here, it shows you the available IEC 61852 devices, which are the devices you have in your project and where you want to add them. Specifically in the IEC 61852 station communicator station. IEC 61852 station communicator. So you can take your IDs, select them all, and then download them to your system. But before I take this step, I have something very important here. I can apply this to all the ones you have, and thus this is the first time saving step. It saves me time and effort instead of pressing and adjusting through what, right? So I come here, for example. The first one I will name, for example, _01. And for example, the second relay, I will name it, then I select score, 0.2, just like that then. On the first relay and the second relay, and I come and tell it to add them to your communicator. And I say, okay, all right, it said to you, okay, the IEC 61852 device description file, ICD, is no longer valid because the device name was changed. You changed the device name. All right, open, save, and close these devices to update the file. This means you should open the files, then save them, and then close them again. Pay attention, this is a very important step. Why? Because you changed. Who did you change? All right, that's good. So you tell him, okay, and that's it. But let's assume I didn't do this step. You still have a problem because the IID name wasn't updated for this release. All right, that's one thing. The other thing is that if you press IEC 61852, it will tell you that you actually have a problem. What's the problem? It will tell you that there's another thing called the IID file and you have an issue there. All right, I don't know what the problem is, or when you try to close it, this message will pop up. This error message ends by telling you that you need to open and close the respective devices, meaning you open the files and then close them again. If I had opened and closed this file from the beginning, this error message wouldn't have appeared. All right, let's say something. Let's say that I will just open this file, not this one, just this file only. All right, I tell it to open, then offline, and then okay. All right, and if I close it again, it will be able to open with me. It will be able to open with me, but let's see. Together it opened, here it is. I will open and close it. If you save, in this case, if you click on any person on a day and click on object properties and set the communication parameters, you will find the IED name, the time. To the communication parameters, what will you find here? Yours. If you open the file and close it again, you must open the file and close it again to prevent the ID name from resetting. You always open the files, save them, and then close them again. Also, just to ensure that an update happens for whom, why. So keep in mind that you should always open your files, make changes, and then close them again. Okay? And this step, I should always do it. You already did it anyway. Why? Because you opened all the files and started making changes to a group of them, right? Okay. Before we continue with our work, Let's go and open and adjust just one to serve us later when we look at some tricks you have. For example, I came here to masking input output, and I said here that I want to insert a group after, and I also named it SAS signals, okay? And I said, okay, I could have done this step from the beginning, but as I told you, I wanted to see the idea of the error message that would appear and go to annunciation and choose a specific signal. I will start giving this signal a name. Let's assume circuit breaker, even though in the first relay it was called trip circuit supervision, right? And I named it, for example, CP faulty. I name it like this and make it through by erasing all the others. Name it here and come here to connect it to yours. Okay, then it will start telling you, here you have it, and you tell it, and you also have its number as 1, and you tell it, I will start the side. And you say, okay. You also have the scene, its number is 1, and you tell it, okay, close, close, I will start saving, and you say, okay. Yes, close it. Now it's saved, and I'm ready with it. All right, okay. Now I'm ready with my files in a group, or I adjusted them, and then I adjusted them back through itself. There is the poor network. I adjusted the intro and adjusted the time synchronization. Then I went back and adjusted the IEC name through the IEC station, adjusted the IEC name through the station, and it adjusted itself. Click on IEC 61850 station. It prompts select a storage location for the new IEC 61850. So confirm with yes. Choose your location, name it CID, and find your file with the .cd extension. Confirm with OK. It will start and open now. Your file, and let's assume I name this part. For example, I will name it like this. OK? And you will find your file there and you will say, okay. It will save in this place and it will open for you now, here it is, and it will open for you now, here it is. Let's be aware that when it opens, it does loading and will take the 2 files that were outside. Look here, it's importing the first device, and the second one, of course, if you had a lot of devices, you would see them all being imported in order, but still it tells you that you have 2 faults here. What are these 2 faults? You have issues. So let's take a look together. When opening the IEC 61850 system configurator, I have 3 important things to work on. The devices, then the network, and then the reports and logs. Okay, I first go to the devices, and I find only the devices there. Network, and then you have the report, right? Okay, I will first go to the one I started with, which is mine. How many devices do you have now? Device 1 and 2. Okay? And where is the GPS? The GPS is also considered a device present in your system. So what do you do with the GPS? You click on the CID, which is your file, and say, add IEC 61850 devices. Great. Now I have this file here, but if you don't have this file, what will you do? You will go and open the C drive. Then in the C drive, you will find something called Siemens, a folder named Siemens. You open this folder and search for a file named SNTB, which stands for Simple Network Time Protocol. You just look for this file, and its extension is ICD. You take this file and say, open. Of course, we have 2 GPS devices in the station, so you take the first GPS and then go back to the second one and say, add IEC and choose the GPS again. Great, well done, folks. Okay, now I've entered everything I have. Then I go to the up network. Here in the network, we will find something called new devices. And here, the devices already located are present. So I start doing drag and drop and place them all down here in the same spot. What is the cause of the error message that appears for you? If you come and hover over any relay, you will find the error message written next to it. And of course, as you can see, you have the subnet mask. So here, as you said, we are cautiously hitting 0. What does this mean? It means that here we said that I could simply right-click on each relay, go to object properties, and then set the IP address, subnet mask, and gateway. However, as I told you, if you have more than one relay or a large group of relays, it would take a lot of time. So here I can set the IP address, subnet mask, and gateway all at once through this network, and all the relays are simply listed one below the other. As for the IED name, I have already set it up using the IEC 61850 communicator. The IEC 61850, the IEC 61850, the IEC 61850. I will go to the primary relay and enter the IP address according to the network you are working with. 10.22.91.C5 with a subnet mask of 255.255.255.0 and a gateway address of 10.22.91.31. The network you are working on. So you have 1022.91 like Mr. .5, and your mask if you have one file 255.255.255.0 and yours is 10.22.91. like 31. For the second relay, errors shift to 10.22.91.6, subnet mask 255.55.55.0, gateway 10.22.91.31, GPS requires ID 10.22, durable 55.0. And finally, you have the gateway 10.22.91.31. You'll find the same thing, the same gateway address here. Then you go to the GPS. It will ask you for the IP address. Then you want to do 91.90.10 and 255, those. And 10.22.91.31, and also the last one, you'll start the last one with 10.22.91.11. And your mask is 255 3 times. This way you'll find that all the errors are gone from your side. 31. This way you'll find that everything sorted from my work. So I have completely finished the topic and finished the time topic. So in a simple way, I managed to finish the topic. Well, if I only reach this stage, I haven't finished all my work yet, but I will close it. I will press first, okay? When I come to tell him, he will say to me, be careful. Changing the IEC 61853 station also affects national materials. So it tells you that after you perform this save, it will start changing these parameters in the SIPROTEC device. So you say, oh, okay, then you close it. If you come here afterward to any of these relays and click on it, it will show you the object properties, and then you go to the communication parameters. Okay, you will find here the IP address, subnet mask, and standard gateway are still the same. Why? Because after that, you are supposed to come here to the IEC 61852 station and right-click object properties. Then go to something here called update. We will go to an item called update. Here, you will find your release available for the device present in your project. This is in a column called P and a column called D. The P stands for parameter set updated, and the D means device update. What does this mean? If you see the check mark under P, it means everything is updated. However, if you see it under D, it means you need to update this device because you made a series of changes. Inside, or you might have even made changes inside. So you come to tell it what you want to do. So now it starts to take the settings you have set, whether it's the IP address, subnet mask, and things like that, it writes them to your device files that are here, and that's what we will see together. That's why I didn't want to continue and go into the data set and report. I said, let's finish this part first and see it so you understand how it reflects on your devices. The most important thing, of course, in anything you work on in the scenarios is to make sure you have 0 warnings and 0 faults exactly. On the right, say close. It's not finished yet, or it hasn't finished. You need to see the check mark here next to the P, then say close. So suppose now, just as it finishes, suppose now it's done. Here is the update. Suppose now inside this update or inside the device, you have, for example, 30 or 40 devices. So quite simply, if you press the letter P or the letter D, it will start rearranging for you so that only the files that need an update are brought to the top. Why? Because you found an update for it. All the parameters or all the devices will take a very long time, whereas you might have only changed one device. So as soon as you just click on your device, it will start bringing up the devices that need an update to the top. You select the first one, mark it, and tell it to update selected parameter sets, and then you say, okay. Now, if we go back to the release again and select object properties communication parameter, what will we find? We will find the ID address, subnet mask, and gateway all recorded. Okay, if you want to change them, you can change them from within the IEC. Can you change them from here? Yes, you can select manual change and modify them, but of course this is not recommended at all. Keep all your work within the IEC station because it is organized and can adjust everything for you to avoid errors and reduce your time. Let's open the IEC and continue our work. Okay. We have performed the device operation through other devices, which is GPS, and you can do the naming process like GPS 01 and the other GPS 0 whatever. You might see, for example, an error message, perhaps not matching the naming, and the other GPS 0 whatever. For example, this one is named GPS_02. Now you are done, and you have configured the network with the IP address, subnet mask, and gateway address, and so on. So your whole story is to then go to reports and logs. Here we will start together with step number 2, which is setting up your data set. All right. Okay, for step number 2, I will open the first one for you, which is the first relay. Okay, in the first relay, I had a set of, and a set of. Now, if you look down here and go up a bit, you will find a set of what we used to call control and investigative control. The auxiliary uses, the assistants, we continue system, all right? So where was my first signal located? It was located in your section. Then what do? I start looking here for what? For your section, correct. Now you have the signal that was in the differential. Was it a signal that was originally embedded and pre-configured in the SS, or was it a signal you added in the extended system interface? No, actually people added it in the extended system interface, so you won't find it under the word protection. So it is present in the extended. Open the extended and look for my GGIO here. Open the GGIO and you will start to find what? You will find the differential second harmonic, which is the signals that the signals that you added. So quite simply, you can start dragging and dropping it into your file. As soon as you place it, it opens protection for you in something called protection, which is the logical device. Then here you have your data set, which is the first data set. So, of course, if you drag this second one and place it in the relay itself, it will open a new data set for you. But I don't want a new data set. I want to add all my signals into one data set. So I start again here by dragging the second file and placing it inside the same data set, doing drag and drop within the same data set of mine, the same one of ours. So these are the 3 signals that are standardized, exactly as you have them. Very nice. Okay? And where is the generic one? The generic ones were when we mentioned them in your matrix. As soon as you marked it with the word system interface, it would open up and tell you what the logical device was called. Yes, let's remember it like this. It was called control. And inside control, it was called Giga IO. How many Giga IO? 1. But I had named it after the word control. I wrote the word SS. Exactly. There's SS, then Giga IO 1. If you open it, you'll start to find a set of signals like TCS, fill, DC, and protection on to off. Who are these names? These are the names that were present in the long text. That's why, remember when I told you, it's very important to name the long text. Because you have display text. If you named them in the display and left the long text, you would come here and find them by default, present as they are, or the default names. So here, you name the names that can give you an indication of your signal. All right, so I will take trip circuit supervision fail, which was a generic signal through a binary input, and this is what was output from the logic that came to me from the CFC. And this is your double point. What is your double point? This way, all the signals are set in one data set. If you have a group of other signals that you want to place in a different data set, you can put them in a different data set. No problem. You can divide them across more than one data set, and you can place them in a single data set. It requires a set of measurements. You can open the measurement and go to the measurement logical device. Logical or logical node under the word, logical device, which is then underneath it, you start to find that you have something like what is considered yours again. So here you have the one you open. You go to the mix view, which is the logical node, open it, and then you find the amperage, which is considered your data object. Open it, and then you find your data attributes, which are phase A, phase B, phase C, and the neutral. Then open the phase-to-phase voltage, the frequency, and so on. You start to take all your amperages. Okay, now I have finished the data set. Go to step 3, which is the report control block. Which one is it? So I start by clicking on my data set and tell it to connect this data set with that report. Okay, this data set, how many servers do you want to send it to? Maybe at your station, for example, to your team and engineering, and you want to send it, for instance, to others. So you might have, for example, 4, 5, or 6 servers, and you want to send them to different locations. Depending on the number of places you want to send it to, you start clicking on them again. And you say, insert report, right-click, insert report, right-click, insert report, and so on. Nice. So what type are these reports you've selected? As you can see now, look here. It says unbuffered report control block. It says unbuffered report control block. How many reports can you download here? You have 12 reports, confirm. So if you, for example, save your station and it tells you that you have 4 locations where you want to activate the data set. So You linked the data set to 4 report control blocks, and you have 3 data sets that you can link to 12 report control blocks. But if you have more than that, you'll stop because you don't have the capability to connect to more than 12 report control blocks. Therefore, it's preferable to try to condense your signals within a certain number of data sets so that you don't exceed the number of reports, which equals 12. Each report you stand on, you can set a buffering time for it, and you can also specify a buffer time. You can tell it whether you want a buffered report or an unbuffered one. For instance, if you tell it buffered report, you can say, okay, it has been converted to buffered and placed here at the end. Then you can go back and tell it, no, I want an unbuffered report, depending, of course, on what comes to you or the request you receive from your client at the station. All right, then it's based on the change you made in your setup or in your configuration. All right, and as it tells you here, this will happen automatically with all your settings, or you can change your configuration to make it 2 or 3 depending on the number of changes, so you know how many times you've made changes. And with that, you have completed the CID file for the first relay. So what will you do for the second relay? We come here to say something very simple. You are now on the first relay. For example, you have a typical 3.4 from it, and relay 2 is also typical 3.4, and so on. Let's assume now that the first relay and relay 2 are typical. What should I do? I won't go to relay 2 and create a new data set and start adding signals from scratch. So what should I do? I can go to the first relay and tell it to copy this data set, then come here. To relay 2, right-click and tell it to paste. Priest. And I said priest, okay. What problems do you have? What are the warnings you have here? You will simply find the warning that you told it several signals. You have many signals here, even though in the next relay you haven't actually set up the masking input for these signals, which is why it didn't include them. And it added only 1 signal. All right, here is the trick I mentioned to you when I was talking about the matrix. When I told you that I would add a signal and program it with binary input number 1, but I will name it CB voltage, even though in the first relay it was called trip circuit supervision fail. But automatically, when you took it from the first relay and placed it in the second relay, what happened? It was automatically placed with the same name that was present in the long text of the second relay. So you don't need to worry or be afraid of this idea of how you will copy and paste them when they have different names. No, copy and paste them. Why? Because this is considered a generic signal. What does that mean? It means you created it in the first place. You didn't take the signal directly. You took the signal as a generic signal, and this generic signal is what you defined here. So why is it that someone doesn't understand that this is a binary input number 1? He understands that this signal is a generic signal, and you named it trip circuit supervision somewhere. Therefore, you copied and pasted from the generic signal and placed it in another relay. In the other relay, this generic signal already has a different name, so it automatically took it. Here, something very important appears, which is what it tells you. It tells you there is an advantage, even though in the theoretical videos I told you that it is preferable to use the standardized logical node. What does this mean? However, it is preferable at your station to use the generic signal. Why? Because it tells you that if you come to your matrix and put, for example, 20, 30 generic signals and connect them to logics inputs and a lot of other things. The generic signals are present here in the dataset, and you can copy-paste them regardless of how their programming looks. So you have fixed 2 things. First, when you copy-paste them from one relay to another, they come down with the same thing regardless of how they are programmed in the masking input or in the other relay. The second important point is the idea that if you go back and change the programming of the generic signal you placed from binary input 1 to 2 or from 2 to 3, you won't have any difference occurring within your dataset or within your CID file. This is because the CID does not see what it is programmed with. It only sees that it is a generic signal regardless of what it is programmed with. Once you've finished all your work or everything is complete, you start by telling it, okay, I'm done. You close. What do you close? You close your file. All right, so what's next? You right-click and then tell it, you'll find them here as well. And then you start telling it, I want to optimize your settings. And assist in gathering. He will get rid of the realities. Oh, after getting rid of the realities. Okay, very nice. We will see how we can get rid of the realities. But there is a part I mentioned to you at the beginning of the video. I told you at the beginning, when you get rid of the realities, it is preferable to see which functions you need to close so that they do not change afterwards. All right, that's fine. When you perform this action at a later time, you might encounter your current signature or the one you have previously inserted already in place. This can lead to confusion or errors if not addressed promptly. It's crucial to understand that timing plays a significant role in this process. For instance, if you delay, the system might not recognize the new input as intended, causing discrepancies. Therefore, it's advisable to act sooner rather than later. To ensure everything aligns correctly, consider the implications of waiting too long, such as potential mismatches or the need for additional verification steps. By addressing this early, you can avoid unnecessary complications and ensure a smooth transition. And tell it offline normally. And you have the 3 for the differential. You've already made them on, okay, I'll just start by coming here to the differential and tell it what, and tell it, okay, okay, fine. And then I close my file and tell it save. Done. And my capabilities, I leave, okay, close. When you decide to open the IEC 61850 standard once more, and we proceed to navigate towards our specific report section, ensuring all necessary details are covered. Oh, it brought you 3 warnings. If you open this state, you will find 3 signals here that were related to the differential second harmonic, which have disappeared. So even if you go back and open your settings offline and enable them again, your signals will not return. You will have to put them back into your CID file. So what is preferred in this case? It is preferred that if you want to disable the function, do not disable it globally from the device configuration. Instead, you can open the setting group and turn the function on or off. Of course, we encounter situations like this in stations when they ask you to disable the auto reclosure. You don't necessarily have to go to the device configuration and disable the auto reclosure from there. Leave it enabled and keep the signals you are using in the CFC and SAS as they are. Then go to the setting group and to the auto reclosure and turn it off. Therefore, if you come to find them, they will remain as usual, and their signals are linked to your dataset very naturally and are connected to you. The CID file will not have any changes at all. Let's finish this. It will leave the auto reclosure. You will come to open the IEC station once again. We will look at our signals, and we will not find an additional signal again. You need to do a drag and drop and place them on the CID page, which is not present. You will go to Extended and then go to JGIO and place 3 signals, drag them, and put them here, then close again. And finally, you also do a right-click on Object Properties and then perform an update. Great. So how will I create a CID file? Quite simply, right-click, Export Device. But this time, instead of DX, I will choose a CID file. Better? Great. So now how do I simply take mine and say what to it? But this time, instead of choosing what for it, I come to choose for it, I say to it, and then say, okay, all right. And the CID file, of course, you can, through the station itself, while you have the station open, export the CID file for the entire station, which contains a large number of Siemens relays, and then you start by saying export here. And you will tell it that you want to export your station, so it will tell you the CID file, and you decide where you want to save this file, and with that, we have finished the idea of how to create the CID file in Siemens. God willing, I will also try to make another video on how to exchange data between Siemens devices.